Now it said if your matrices are equal, all corresponding entries are equal. So here, that's what our equal sign is indicating, that these matrices are equal. So when it wants us to find the value, we just have to say, okay, which entries correspond with which entries. So if we're trying to solve for x first, x plus 5 corresponds with the value 2. So x plus 5 will equal 2. What will x equal? Either in your head or actually solve it out. X will equal -3. Okay, so what about letter B? Nope, not letter B. We haven't finished letter A. So we solved for X. We also need to still solve for Y. So 3Y corresponds with which spot in your first matrix? 6. So 3Y equals 6. Divide. Y will be 2. So that's it. So when your spots correspond, because your matrices are equal, that's how you guys would be able to solve for your different values. So if we look at letter B, if we're trying to find y corresponds with 6, x corresponds with -1, z corresponds with 4. So in that one, there's not even any solving to do. It's just a matter of understanding which spots correspond with which spots. And y is 6. So that's not too bad. So let's look at adding and subtracting these. Okay, so just like when your matrices are equal, your entries correspond with each other. When you're adding and subtracting, you want to keep the entries that correspond with each other together as well. So if you're looking at letter A, and it wants us to add these two matrices, you're just going to go spot by spot, and if you have two 3x2 matrices, you're going to end up with a 3x2 matrix. So 4 plus 2 equals 6. 7 plus -5 is 2. And you keep going from spot to spot. 0 and -3 is -3. -2 plus 2 is 0. 1 plus 0 is 1. -6 plus -4 is -10. Just don't forget your brackets. And that would be it. So those two matrices added together gives you the matrix, still a 3x2, of 6, 2, -3, 0, 1, and -10. So if we look at B, it wants us to add a 2x2 matrix with a 1x2 matrix. If your dimensions are not the same, you cannot add them. So your dimensions have to be equal in order to add or subtract. So if we look at letter C, 3x3 and a 3x3, so we'll be able to combine these. But just pay attention to your sign. It wants us to subtract here. So still go spot by spot. 1 and 2, -7 and -2, 3 and 0. Just be careful with your minus. So I'm going to write it just down here where I have a little more room. So 1 minus 2 gives me -1. -7 minus -2 becomes plus. So -5. 3 minus 0 is 3. Next row. 2 minus 5 is -3. 0 minus -6 is +6. So 0 plus 6. -1 minus 8 is -9. Third row. 4 minus 10 is -6. -4 minus 2 is -6. And 2 minus 12 is -10. So just make sure you're keeping it neat enough so that you can read it and I can read it if I'm trying to grade it. I just should be able to see the spaces in between each one and be able to tell what your individual entries are. And then letter D, it's not adding or subtracting, but it is an operation with the matrix. So if you guys saw -3 out in front of x plus 5, you guys would think to distribute it in, right? Well, you do the same thing here. You have to distribute the -3 inside to every single value. So every entry is going to be multiplied by -3. So again, I'll just write it down here. So 1 times -3 is -3. 2 times -3, 3 times -3, 9 times -3, -3 times -2, -3 times 6, -18, -3 times 10, -30. -3 times 4 is -12, and -3 times -5 is +15. So that's all there is to it. So here we just have some more operations for number 3. It gives us the two matrices, matrix A and matrix B, and it says find -2A plus B. So -2 is being multiplied by A, and then just plus whatever B is. So we will be able to add and subtract them because they're the same dimensions, 2 by 3 and a 2 by 3. So let's multiply the -2 inside to A first. So -2 inside here to everything. So that will become -2, -6, 4, -8. Anything times 0 is 0, and -2 times -5 is 10. So that is -2A. Okay, now let's add B to it. So 3, 1, -5, 0, -7, 2. And then just add them. So this will become -2 plus 3 is 1, -6 plus 1, -5. 4 plus -5 is -1. -8 plus 0 is -8. 0 plus -7, -7. 10 plus 2 is 12. So just, again, add all corresponding entries. And that is that. All right, let's keep moving down here to number 4. Number 4 wants us to solve the matrix equation. So just like in number 1, we are solving for that variable x. It's just that it's not quite as simple as just seeing, okay, this entry corresponds with this entry. So what we need to do is still try to isolate our variable. So when you're working with matrices, you want to work with the matrix as a whole, moving it as a whole from one place to another. So if we look at the first one, 3x plus that 2 by 2 matrix, -2, 1, 3, and 0, we're going to subtract that matrix over. So we're going to subtract the whole thing, -2, 1, 3, 0. And just like with any equation, we always have to keep it balanced. So we have to also subtract it on the left-hand side because that's where we're actually moving it to, correct? And on top of moving that matrix over, I'm also going to distribute that 2 into the matrix that's already over on the right-hand side. So on the left, we'll be left with just 3x equals that matrix being multiplied by 2, that will become -2, -8, 0, and 12. We're now subtracting that matrix that we just moved over. So -2, 1, 3, and 0. So I'm going to keep the 3x, and I'm going to combine those two matrices on the right now. So -2 minus -2, be paying attention to which operation you're doing, becomes a plus. So -2 plus 2 is 0. -8 minus 1, -9. 0 minus 3 is negative 3, and 12 minus 0 is 12. So if we're trying to solve for x, you guys would right now just divide by 3 and call it a day. Okay, so dividing by 3 is the same thing as multiplying by 1/3. The reason we have to multiply by 1/3 is because you can't really divide a matrix by a value. You can only multiply a matrix by a value. So, or we don't write it as division. So by multiplying by 1/3 is the same thing as dividing by 3. So multiply each entry by 1/3, or essentially divide each entry by 3. So x is going to be the matrix value of 0 times 1/3 is 0. Negative 9 times 1/3 is negative 3. Negative 3 times 1/3 is negative 1. And 12 times 1/3 is 4. So we did solve for our x. It's just that it's not a single value. X is actually equal to a single matrix. But it's still essentially just following your order of operations. Just making sure that you keep your matrix together as a whole as you operate with it and move it from here to there. So let's look at letter B. Okay, so for letter B, we have 2 times, in parentheses, 2 matrices added together equals that third matrix. So what's going to happen is order of operations says do what's in the parentheses first, regardless of if it's regular numbers or if they're matrices. So we're going to combine these 2 matrices together first and then distribute the 2. So I'm going to keep the 2 out front. And how do we add matrices? We just add the corresponding entries. So 3x plus 4 and I'm going to keep it as 3x plus 4 because we can't add an x value and a non-x value. All right, and then negative 1 plus 1 is 0. 8 plus negative 2 is 6. 5 plus negative y is 5 minus y. So that's your matrix on the left, still with that 2 out in front. Equals the matrix that we still have on the right, which is 26, 0, 12, and 8. So now that I have one matrix on the left-hand side, now I'm going to distribute the 2 inside. So this will now become 6x plus 8. Every single value gets that 2 multiplied by it. 0 times 2 is still 0. 6 times 2 is 12. And 2 times 5 minus y becomes 10 minus 2y. Still 26, 0, 12, and 8 on the right. So now that we're down to just a matrix and a matrix on each side of our equation, now it's like that very first one that we did where we can say, okay, 6x plus 8 equals 26 because they correspond in the same spots, and 10 minus 20y, or 2y, equals 8. So 6x plus 8 equals 24. 10 minus 2y equals 8. So I would subtract the 8. And get 18. I was like, what? That is not supposed to be 24. That is supposed to be 26. Let me fix that. There we go. Now we get 18. Because 24 minus 8 is not 18. Divide by 6, and you get x equal to 3. Over here on the right, you subtract the 10, get negative 2y equals negative 2. Divide by negative 2y is 1. So in this case, you were solving for an individual value for x and y. And those would be your two solutions. Again, if you guys are working through any of this and you're confused at what I did, just please come up and make sure that you guys ask me.